Hello students, in this lecture I am going to start new chapter operational amplifier. Let me begin with the syllabus. These are the contents: concept of operational amplifier, ideal characteristics of operational amplifier, virtual ground concept, inverting and non-inverting op-amp, voltage follower, zero crossing detector, addition circuit using OPAMP. So let me begin with one by one. So concept of operational amplifier. What is operational amplifier? Amplifier is a device which converts low level input signal into the high level output signal. It is called amplifier. The process which does this is called amplification process. Similarly, here in operational amplifier, this is does the amplifier work. Along with that, some operations, and those are the mathematical operations, which are nothing but addition, subtraction, multiplication, division, etc. Hence the name operational amplifier. In early days, when there was no digital computer were there, that time this op-amp were used to do the performance of mathematical work. Nowadays, in the digital computer, that work will be done again with the help of this IC only. This op-amp is a chip. It is an integrated circuit. It is an IC. It is basically made up of silicon material. Inside that, many resistors, capacitors, diodes, transistors will be connected. It will be connected together in such a way that it produces the required output. So this is what about the basics of operational amplifier. This can be explained with the help of symbolic diagram and pin configuration. Here, these two diagram shows the symbol and pin configuration. This symbol consists two input terminals and one output terminal along with two supply terminals. The terminal which is connected to the positive end is called non-inverting terminal and it is denoted with V1, and negative terminal it is called inverting terminal and it is denoted with V2. And this positive VCC and negative VCC are the supply for this operational amplifier, and output will be collected at the output terminal. So if you see pin configuration of this IC, it total consists 8 pins, and those 8 pins are connected in such a way that 4 pins on the one side and 4 pins on the other side. Hence it is called dual inline package. That is what 8 pin DIL, dual inline, on the both the sides pins are connected. Pin number 2 is for negative and pin number 3 is connected to the positive. That means this one is inverting terminal, pin number 2 is inverting terminal, and pin number 3 is non-inverting terminal. Here pin number 4 is for the negative VCC and pin number 7 is for the positive VCC. Output will be collected in the pin number 6. Pin number 8 is not connected, which can be used for the future applications. Here on the ICs there will be notch will be provided and with the dot mark, and this indicates that this notch should be always up, and this dot indicates that the pin number 1 begins there. So in that way you can identify the IC pin numbers with the help of this dot, and how to place this IC in the IC trainer kit or as well as the some instrument. It is based on the this notch. So this is what about the symbol and pin diagram of operational amplifier. Let me begin with its types. Here again this diagram shows the symbolic representation only. Now I am interested in the types of operational amplifier. This operational amplifier is classified basically into three types. How it is based on the signal where you connect. Here two input terminals are there, so at both the side you can connect the signal, or you can connect source between the two signal. Hence total three ways are to connect the source or signal. Hence it is classified in three ways. If you connect source or signal to the positive terminal, then it is called non-inverting operational amplifier. If you connect the signal at the negative terminal, then it is called inverting operational amplifier. And third one, this is you have connected the signal or source between both the terminal, hence it is called differential operational amplifier. So hence a operational amplifier can be used as inverting, non-inverting and differential amplifier based on the where you are going to connect the input signal. In this way operational amplifier is classified. Now next one is ideal characteristics of operational amplifier. Every device will be having its own characteristics. In the similar way, operational amplifier also have its own characteristics. The characteristics which we expect ideally, then it is called ideal characteristics of operational amplifier. So here the input impedance of the OPAMP should be very high. That means we expect ideally infinite, but practically it is not possible. Practically we may get in terms of mega ohm. Mega is nothing but it is very high value. So operational amplifier having very high input impedance input impedance, that means it will be having input impedance or input resistance. This will be very high. The reason behind it is whatever voltage you apply, that should apply across the input. There should not be any change in the input level, hence its input impedance should be very high. As input resistance is very high, here in terms of mega ohm, and ideally we are speaking it is infinite. If it is offering very infinite resistance, the current flowing through this terminal will be 0 only. I is equal to 0. Here I is equal to 0. So no current is flowing through these terminals. That is what the meaning of that very high input impedance. Now it should have very low output impedance, that is ideally 0 we expect, but practically it is not possible. It will be in terms of ohm. It may be 10 ohm, 20 ohm, 70 ohm, 100 ohm, like that. But comparing with this mega ohm, this ohm is very small value, and we expect that output impedance of this operational amplifier should be low. If it is 0, then the output voltage here what we are getting, it will be maximum. If there is a resistance high value, then some voltage drops takes place here, and at the output the voltage gets decreases. That should not acceptable. That is not acceptable value. Hence this output resistance should be 0, and practically will get in terms of ohm. It should have very high bandwidth, that means infinite ideally, but practically it is not possible to get infinite, but it should operate for 0 to megahertz. That means if you are connecting any source, and if this source is having a, it may be having 1 hertz, or it may be 2 hertz, or it may be 10 hertz, 10 kilohertz, 1 kilohertz, etc. It should operate for any frequency. That is what we expect, infinite, but practically it is not possible. But practically in terms of megahertz it should allow to operate. So it should be, value should be in terms of megahertz. And high gain, that means open loop gain of the operational amplifier is infinite, that is very high value, practically it is not possible to get infinite. It should be in terms of 10 raised to 5 to 10 raised to 6. 10 raised to 6 again, it is once again in terms of mega value. So the open loop gain of this operational amplifier is very high. Ideally speaking, it is infinite, but practically if it is speaking in terms of mega value, it is much very high value comparing with the other amplifiers. When we speak, voltage gain of this amplifier is 100, 200, 1000, like that. That itself we used to tell very high value. Now here it is in terms of 10 raised to 6 lakhs together, so it is very high operational amplifier gain. Along with that, some other two characteristics like slew rate and CMR are both should be high. Here CMRR is nothing but common mode rejection ratio. It indicates how well it rejects the common voltages and how well it amplifies the difference in the input voltages. That is what about the CMRR. And here slew rate is, it should be very high. What its slew rate says, how fast that operational amplifier responds at the output to get maximum output at no time. That means at 0 time it should get the maximum value, so that it should operate very fast, so that slew rate should be very high. Now along with this ideal characteristic, I would like to explain another point, that is feedback circuit. So what is feedback circuit, that we'll see now. So this is called open loop connection, or open loop gain of this operational amplifier is in terms of mega. If I want to control the gain of this open loop gain operational amplifier, then what is required? There is a feedback circuit is required. If you want to control that gain, then you need to connect the signal, output signal, to the input side. If you connect part of the output to the positive terminal of the op-amp, it is called positive feedback. If you connect part of the output signal to the negative terminal, then it is called negative feedback. To control this high gain of this operational amplifier, then there is a need of negative feedback. If you connect positive feedback, again its gain value increases. We cannot control. To control that open loop gain, we required a negative feedback, and that we are going to discuss in the next concept. So this is what the explanation for today's class. What we have covered: what is operational amplifier, its basics, symbol, pin configuration, types and ideal characteristics, along with the types as well as feedback circuits. Thank you.